Question number 3. A trolley while going down an inclined plane has an acceleration of 2 centimeter per second square. What is given? Acceleration. What will be its velocity 3 seconds after the start? What do you understand by the meaning 3 seconds after the start?
Final velocity
Is question mark. We have to find the final velocity. What is given to us?
Time.
And what is given? One more thing is given.
Initial velocity.
How much is initial velocity? 0. Because it starts and now see it is going down the plane, means it is moving downwards, and the acceleration downwards will also be positive because it is going in the direction of the motion. Yes or no?
Yes.
So start writing. Given acceleration is equal to 2 centimeter per second square. We will keep it in centimeter only. Doesn't matter. So that our answer will also be in centimeter per second square. Time is equal to 2 seconds. That's giving us the time is 2 seconds. After starting the motion from rest, that is initial velocity u is equal to 0. Yes or no?
Yes.
To find final velocity v, a, t and u is known. Which relation are we going to use? First equation of motion. Very, very good. Chalo, start doing it. Start doing all of you quickly. According to the first equation of motion. What is that?
V is equal
equals to u plus
velocity.
Do it. V is equal to 0 plus 2 into 2. I can do it like this also, according to the first equation of motion. How much is V?
4
For what? For what? For what?
centimeter.
Centimeters per second. 4 cent, because the acceleration is in centimeter per second square. So velocity will also remain at centimeter per second. Yes or no, children?
Yes. Yes, sir.
Huh.
Yes.
So what is my final answer statement? The trolley will attain a velocity of 4 centimeter per second after 2 seconds of starting the motion. Yes or no?
Yes, sir.
Question number 4. A racing car has a uniform acceleration of 4 meter per second square. What is given?
acceleration,
Max.
What distance will it travel? Again, S is equal to question mark. In 10 seconds, T, after start. So again, what is given to us? After start means what?
Initial velocity.
How much?
Initial.
0,
0. So question number 4. So let us put that given part.
Sir, it is after 3 seconds.
3 seconds they are saying. Why did I read 10? 10 seconds is there in my book. See na?
Question 3.
question,
Acha, question 3 is 3 seconds. Okay. Our time was 3 seconds in question number 3. So do the changes, children. Beta, first I'll write this. Acceleration is equal to 4 meter per second square. 4 meter per second square. T is equal to 10 seconds. T is equal to 10 seconds. Initial velocity u is equal to 0 meter per second. Okay. Now make the necessary changes in the first part, all of you. This t was 3 seconds. So 2 into 3, 6 should be the answer. Yes or no?
Sir.
yes, sir.
6 centimeter per second after 3 seconds of starting the motion. Do the changes. Now in the question number 4, A, T and U are given. They are asking us, what have they asked us? What have they asked us?
Distance it will cover.
Means what to find?
Speed. Final velocity. Fine.
Why final velocity, beta? Distance covered is directly S, displacement.
Yes.
And which equation of motion?
Second equation.
Second equation. S is equal to ut plus half at square. Kitna easy hai? Why do you need V? We don't need only V. Directly we can find out the distance. According to the second equation of motion. S is equal to ut plus half a t square. Put the values, get the answer, all of you. S is equal to 0 into 10 plus half into 4 into 10 square. 2 ones are 2 twos are. So what is the answer?
100.
400 meter.
अरे कैसे रे 400?
200.
हाँ 200. Yes or no?
Yes, sir.
Yes, sir.
Then why do you say 400? S is equal to 200. What 200? 200 what?
Meter.
Meters. Yes. So what am I going to put over here? Final answer statement.
Racing car will cover 200 meters
Correct.
After 10 seconds.
after 10.
That's it. Yes. So the racing car will cover a distance of 200 meters after 10 seconds. Good. Next question number 5. Let me look at the question, what they are saying. A stone is thrown in vertically upward direction with a velocity of 5 meter per second. What is this 5 meter per second?
Velocity.
Which?
Initial.
Initial velocity, because it is initially thrown with a velocity. If the acceleration of stone during the motion is 10 meter per second square, what is 10 meter per second square?
Acceleration.
In the downward direction. Means what? Means what, beta? Where is the stone thrown?
Deceleration.
Yes. See, the stone is thrown in the upward direction, but this acceleration due to gravity is in the downward direction. Means A has to be negative over here. Yes or no? Because it is traveling against the acceleration. Are you
Yes.
understanding?
Yes, sir. Yes, sir.
Yes, sir.
What will be the height obtained by the stone and how much time it will take to reach there? Just a minute. Suppose if I was to draw the figure, stop all of you and pay attention over here. Suppose this is the ground level and we throw a stone vertically upwards and it reaches that point. Say from ground level O, it was thrown upwards and it reaches a point A. So what is this OA?
Height.
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 Initial.
Height means what? The distance traveled, S. Yes or no? The distance traveled by the stone is this. Correct hai ki nahi?
Yes, sir.
They are asking us the time required. That is the question mark. The height obtained is also the question mark. Initially, it was thrown with a velocity of
5 meter per
5
second.
meter per second square. And the acceleration was negative. U is known, A is known, T is not known, S is not known. What to do? Because we needed A, T and U to find out S. But right now T is not known to us. Only A and U is known to us. Who can help me in this? Who can help me in this? One more quantity we know. Who will tell me which is the another quantity that we know? Yes, who can tell me which is the quantity that we know?
Acceleration.
Likha na, given C. I'm writing. Initial velocity U is given 5 meter per second. Acceleration A is going to be minus 10 meter per second square because it is in the negative direction that is given to us. Just a minute. Huh? I will remove this and I will put it over here. Minus 10 meter per second square. One more thing is given to me. Who will tell me which is another one thing that is given to me? Time is not known, distance traveled is not known, but one more thing is known. Which is that known thing to us?
Final velocity.
Final velocity will be
How much?
same.
How much? How much will be the final velocity?
10.
0. 0.
0 meter per second. Now, why 0 meter per second? All of you will look here now. Pay attention. Just a minute. Just a minute. Now, suppose this was an object which I am throwing upwards with a velocity of 5. The acceleration is downwards 10 meter because acceleration due to gravity is in a downward direction of 10 meter per second square. My object is moving upwards. So acceleration was negative. What happens? See, it goes up to a distance, it stops and then starts coming down. Always remember, whenever I throw a particular object, it stops and then comes. See, it was going up, now it stopped and it started coming down. Yes or no?
Yes.
And they are
Yes, sir.
exactly asking us the same thing. How much did it go up? How much did it travel? How much is the distance that it can go up and in what time? So it will go up and stop and then start coming down. So the final velocity when it stops is going to be 0. Am I right?
Yes.
Yes, sir. Yes, sir.
So that is what I'm going to write over here. Final velocity 0. I will write it over here. Again, for my own understanding, not for anybody else. Final velocity is equal to 0 because the object stops at the highest point before it starts its down travel. Yes or no?
Yes, sir.
Because the object stops at the highest point before it starts its down travel, its final velocity is going to be 0. Now, what do we have to find it out? Two things we have to find. Which are those?
Height and time.
Time.
And time.
Distance.
So, to find maximum height reached, maximum height reached, that is equal to the distance traveled by the stone actually, that is equal to s. And second thing is, I hope you have drawn the figure.
So,
Time required t. Now see, v, a and u are known. So which equation are we going to first use now?
first
Third equation.
law of motion.
First equation of motion. So solution according to the first equation of motion. What do we have? No, v is equal to u plus at. Put the values. 0 is equal to 5 plus minus 10t. Minus 10t comes here and becomes plus 10t. Yes or no?
Yes.
10t is equal to 5. T is equal to 5 upon 10. How many?
So,
0.5 seconds or half a second. 0.5 seconds. Yes or no?
yes.
Yes.
And
Yes.
and now according to the second equation of motion. But let me draw a line. according to the second equation of motion. S is equal to ut plus half a t square. So find it out. Do it all of you. U is 5. T is 1 upon 2. Yes or no? 5 upon 10 or 0.5, let me write. Plus half into what, Ray? What is A? Minus.
minus 10 meter
Ah,
per seconds.
yes. Into 1 upon 2 into 1 upon 2. So 2 ones are and 2 fives are. 5 into 0.5. 2.5 minus 5 upon 4. Do it. 2 upon 5 minus 4 ones are 4. 1 0. 4 twos are 8. 2 0. 1.25. And 2.50 minus 1.25 will give me 1.25 meters. Are you understanding?
Yes, sir.
So what is going to be my final answer statement?
The stone reaches maximum height of 1 point.
Yes, exactly. We'll reach a maximum height of 1.25 meters in what? 0.5.
0.5 seconds.
In half a minute, stone will reach the maximum height. Very, very good. But does somebody take a screenshot of this page and send it on the group? Taken the screenshot? Has anyone taken the screenshot?
Yes, sir.
Yes, sir.
And send it on the group also. Thank you. So these were the 5 questions, important questions. Finished all of you? Are you understanding, children, how we are solving these questions very, very easily?
Yes, sir.
Sir.
Very, very good. Finished writing this answer?
Yes.
Finished. And this is the last part, uniform circular motion. That is the last part, uniform circular motion. And then we have the exercise sum 7, 8, 9, 10. हो गया बस थोड़ा ही पार्ट बाकी है अभी. Okay, all of you are here with me? Just a minute. Huh?
Yes, sir.
Hold on for a minute, all of you. Hello? Right. Now pay attention over here. This is a very, very interesting motion. Another motion, that is a uniform circular motion. Okay, let us read. When the velocity of an object, see, this is again a very important thing. Just a minute. Now you tell me, when do we say that the object is in acceleration? When do we say that the motion is an accelerated motion? Which
When
motion
there
is
is
that?
a change in the velocity.
Exactly. When the change is in velocity. Whenever a velocity changes, we will say that the object is having an acceleration. When will the velocity change? Velocity change means what?
When the speed changes with the time.
When the speed changes. And only when the speed changes, the velocity. What is velocity actually? Definition of velocity: speed along with
Along any
direction.
direction.
Yes. So either the speed must change or the direction must change. That means the velocity will change. The other day I had told you right on the first day itself. If I want to change the velocity, I must either change the speed of the object, either I should increase the speed or I should decrease the speed, or I should change the direction. When I speak about a moving fan, what I can see about the fan is that you see the blades of the fan at every point of time it is changing the direction. Once it is going like this, like this, like this, like this, like this, like this, every time it is changing the direction. And whenever you change the direction, you say that there is a change of velocity. See, fan is right now operating at a constant speed. Speed is not changed, but the direction is changed. And even if the change of direction happens, I will say that the velocity is changed. Though the speed is constant, I have not changed the regulator. 1 पे, 2 पे, 3 पे, जिस पे रखा है उस पे ही है. Speed is not changing, but here the direction is changing. And change of direction means change of velocity. Change of velocity means an accelerated motion, because we know that rate of change of velocity is acceleration. That is why, see, this motion of a fan is a circular motion and uniform motion. Uniformly it is circular, but though it is uniform and circular, the velocity is constantly changing. Hence, it becomes acceleration, uniform acceleration. Do you understand?
Yes.
Yes, sir.
Very
Yes,
important
sir.
point, that a uniform circular motion has now become an accelerated motion. Accelerated matlab kya? It is going to increase the speed at some point of time. And that is why, if you see an example, the farmer, what does a farmer do? He has a rope in his hand and a stone is attached. Lagan movie you might have seen. In Lagan movie, that one boy is there, he's rotating like this and throwing it. The stone goes and hits. You know, when there are birds damaging the fields, or there are birds, you know, who are damaging the crops, what do the farmers do? They tie the stone at the end of the rope, they rotate the rope. Now see, when I'm rotating the rope, it is in a uniform circular motion, and that's the uniform circular motion is actually an accelerated motion. And the moment I leave it, it goes, the stone travels tangentially, and I'm going to explain it to you what is the meaning of tangent, and it goes a longer distance. Do you understand the application of uniform circular motion?
Yes, sir.
we realized we realized this thing, that if a circular motion is uniform, it is going to be a change of velocity at every point of time, because there is a change of direction at every point of time. Change of velocity is going to make it as an accelerated motion. And that is why, you know, the athletes who are doing that disc throw, जैसे हाथ में disc लेते हैं, ऐसा गोल गोल घूमते हैं, they will go round and round, they will take 2 or 3 rounds, and then they will release the disc, and the disc goes very far. Or even that shot put, he will do like this, he will take 1 or 2 complete rounds and then release the shot put. Because of those 2 uniform circular rounds, the shot put or the disc in my hand, in the athlete's hand, has gained the acceleration, and when it leaves, it goes off in a tangential direction. Tangent means what? Now see, there is a circle, you know what, I will explain it to that also, with the help of our diagram. Whenever it is something in a circular motion, at every point of time it is like trying to leave the circle. Okay, if you see over here, See, like this, see, if I consider this rectangular motion, okay, I'm going from like this, starting from A, I'm going downwards, then change my direction, change my direction, change. Only 4 times I had to change my direction, okay, because there were 4 corners. At every corners I changed the direction. If I wouldn't have changed the direction at point B, what would have happened? If I wouldn't have changed my direction at point B, what would have happened? You tell me.
Speed would have decreased.
No. What I'm saying, I started my travel from point A and I don't change my direction at point B. What will happen? I will continue going in the same direction. If I don't change the direction, I will continuously go on in the same direction. Yes or no?
Yes, sir.
But I changed my direction. So if I wouldn't have changed, I would have gone in the same straight line. Then I came over here. At point C, I changed, so I went upwards. If I wouldn't have changed, what I would have done? Gone in the same straight line. Yes or no?
Yes.
Yes.
Same thing would have happened over here if I wouldn't have changed. Same thing would happen over here if I wouldn't have changed. Similarly, see, there were only 4 corners. If instead of a rectangular track, I was traveling on a hexagonal track, I would have changed my direction 6 times. 1, 2, 3, 4, 5, and 6 times I had to change my direction. If I wouldn't have changed my direction, I would have gone in the same straight line like this, or like this, or like this, or like this, or like this. Are you understanding? If I wouldn't have changed.
Yes.
And now, if you try to visualize, remember in Diwali you use that bhui chakkar जो हम लोग खेलते है ना. One is that tree like thing, and another is that circular thing which goes round and round and round. Do you know on the floor it goes round and round?
Yes, sir.
So see that those springs are coming out like this only from that circular thing. Yes or no? Or in this summer seasons, if you see the vehicles, ये vehicle का circle रहता है, your tire of the vehicle, and then exactly like this, in this direction the water splashes out. Yes or no? Or even on your car, you will see these kind of lines of mud happened. Yes or no?
Yes.
Yes, sir.
Because this tire is going in rotational direction. Here this water splashes out in this direction, at this point this direction, at this point this direction. See, and as the number of corners are increasing from 4 to 6, from 6 to 8, number of times I am changing my direction increases. Yes or no?
Yes, sir.
And the more number of corners, as the more and more the direction changes, it slowly and steadily moves towards a circular shape, and ultimately I get a circle. When infinitely many times I have to change, see at every point I'm changing the direction, so it is becoming a circular direction. If at see if I go rectangular, I'm going up, change the direction, change the direction, change the direction. Hexagonal, change the direction, 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 and change the direction 6 times. Octagonal, change, 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 and change 8 times. Similarly, when I have got change at every point of time, change, 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 every change will ultimately make it a circular motion. Are you understanding?
Yes, sir.
Means if at every point of the motion I'm
Yes,
changing the
sir.
direction, yes, means if at every point of my motion, if I'm changing the direction, the motion becomes a circular motion. And because there is a change of direction, this motion becomes an accelerated motion. Yes or no?
Yes, sir.
Because there is a change of velocity, because there is a change of direction, and because there is an acceleration, the moment we release something in this, it gains acceleration, it gains a speed, Just like our car gains acceleration, that uniform circular motion gives the acceleration. The stone travels in a straight line direction, just now as I showed you. If I wouldn't have changed the direction, it would travel in a straight line. So when I release the stone is, earlier the stone was changing the direction when it was in a uniform circular motion. Now when I'm releasing the stone, it is not changing the direction, so it will go in the same straight line. The athlete does the same thing. He first rotates, again rotates with that thing in his hand. He is rotating, again rotating. In 2 or 3 or 4 rotations, uniform circular motion, he will gain the acceleration, and then exactly, see, if I release, even if when you are going to play in your schools the shot put or the disc, why to take that circular motion? To gain the acceleration. And if I release it from here, obviously shot put will go this direction, which is wrong direction. So I should not release it here. Where should I release it? Exactly at this point I should release it, shot put, so that it will go in the same straight line. Even if I release, see, I am rotating, by chance यहाँ पे छोड़ दिया तो पीछे जाएगा, पीछे से आते आते ऐसे डायरेक्शन में छोड़ दे तो इधर जाएगा. So when my hand is like this, I have to release it so that it travels in the same straight line in an accelerated motion and goes the maximum possible distance, because the shot put or the disc has to go travel the maximum possible distance. Yes or no?
Yes, sir.
Yes, sir.
This principle of uniform circular motion being an accelerated motion is used by the farmer, or by the athlete throwing a discus, or by the athlete throwing a shot put. Do we understand?
Yes.
So that's all for the today. That's the last point, uniform circular motion. It's time up. We will stop over here for the day. Correct?
Sir. Okay, sir.
Yes, sir. Chalo, sir. Goodbye, all of you.
Thank you, sir. Bye, sir.